Hi there, I'm Annapurna Agrawal from Smartherd. In this guide, we will have a high-level overview of Angular, an amazing, modern and highly performant framework. In this guide, we will cover what is Angular, the benefits and features of Angular, its basic architecture, various tools to use with Angular, and few gotchas and tips. However, this is not a guide on choosing a framework. Neither are we going to compare various frameworks with Angular. But this will be helpful for you to understand Angular itself. Finally, we are not going to code with Angular in this guide. However, if you are starting to learn Angular, this is a great place to get started, having a high-level overview of the framework. Before starting this, you should be familiar with JavaScript and web processes in general. By the time we are through, you'll have a good idea to make an educated choice on using Angular, or use the details that you get here into perspective as you learn to write web applications in this framework. So let's start off with a little section about what is Angular itself. Angular, what and why. What is Angular? Angular is a framework for developing interactive and scalable web applications. It is an open source platform, thus available for free and open for continuous improvement by the developers community. It is written in Typescript. Angular is one of the many alternative frameworks. There are many alternatives available to address the same issue that we solve with Angular. However, the top competitor now of Angular, I would say, is jQuery. A large percentage of websites use jQuery in the web applications. History of Angular. Back in 2010, the first version of Angular, or AngularJS, was developed by Google. It was built on JavaScript. In September 2016, Google came up with a more modern and performant version of AngularJS, Angular 2. It was written in TypeScript and was completely a different framework as compared to AngularJS. December 2016 saw another release of Angular, and this version was version 4. But wait, where is version 3? Version 3 was entirely skipped. This was because there was a conflict in version number between the Angular and another supporting library in Angular 2. So syncing the versions led to Angular 4 instead of Angular 3. So after 2, we have 4. Currently, as of 2022, we have Angular 13 as the latest version. Angular release and support. Angular releases a major version every 6 months. They package up all the features that are ready, new or updated, and put them in that release. With every release, we get 6 months of active support until the new version is released. But when the new version is out, they extend the support to another 1 year for minor issues or bug fixes, but no new feature is added. By the way, don't worry. Updating in Angular has been made easy with the Angular Update Guide, which guides us to use the CLI tool ngupdate for updating our Angular versions. Updating requires a very little or no manual work in Angular. Now, speaking of Angular versions, the original version of Angular is now officially called AngularJS. This includes all the versions of Angular associated with suffix 1. It may be 1.2, 1.9, 1.5, anything. And the subsequent versions of Angular is simply called Angular. It includes version 2 and beyond. So currently, we have two kinds of Angular. AngularJS, the first generation which was written in JavaScript, and Angular, which refers to Angular 2 or later, written in TypeScript. Features of Angular. Angular is considered to be one of the best and most convenient frameworks to work with. Let us discuss few features that makes Angular as popular as it is. Angular can be used to build progressive web apps fairly easily. Progressive web apps allow a web application to be installed on mobile to give user an experience on par with the native apps. Angular supports lazy loading. This reduces the initial download size for the browser, thereby improving the performance of our application. Angular supports server-side rendering. In server-side rendering, the process of rendering the HTML or CSS and creating the first page view is done on the server itself. This makes the initial page view faster and plays an important role in SEO. Angular update library called ngupgrade. This library allows incremental migration of Angular version from AngularJS to Angular. This allows us to rewrite pieces of our AngularJS application into Angular practically one file at a time. This means we can have AngularJS and Angular together in our application and our app will work seamlessly. Angular also has a number of services and libraries which make development efficient. Like the Angular language service, we can use this to get better intelligence and debugging in templates, thereby avoiding typos. Angular has a fully featured router that works pretty much for all modern frameworks. Angular has a fully fledged form library. This is helpful in writing and validating complex data input forms. Angular is built on RxJS library. This adds to the efficiency in handling asynchronous data in our app. The animation library of Angular is recommendable as well. This is not the complete list of features that Angular has, but some of the important ones that are commonly helpful in a lot of web application. Hello Angular. It's time for some action now. Let us now build a basic Angular app using the Angular CLI. If you are already familiar with Angular CLI, you can safely skip this part. It is just a high-level overview of creating Angular app using the CLI. Don't worry about following along. You can just watch. I'll switch to the terminal. I have already installed and set up my CLI. To create an Angular project for us using the CLI, we just need to use the command ng-new followed by the application name. Let's call it BroadLook. On hitting enter, would you like to add Angular routing? Let's say yes. Which style sheet format would you like to use? I'll use CSS. So here, Angular CLI has created a basic application scaffolding and installed all the npm packages required to run the application. I'll clear this for now and move to the project directory. Let us open this code in our editor. I'll use Visual Studio Code. So here is my Angular project, BroadLook. This is my test file. This node module directory has the node packages. These are the basic configuration files. And here in the source directory, this has the basic code to start an Angular application. The core of the application is inside this app directory. It has the basic pieces of the application, including the single app components. Using the CLI, we can also add another component to the project. Let's add a contact page for us. To do that, we will use the G flag followed by the C flag, which is the component, and then the name of the component. And here, our contact component is ready. Let us see in the visual code. So here in the editor, we have our contact component ready. We have got the template files, the CSS files, and the place to put unit test for this component. We can also run the application from the CLI itself. To do that, we will use the command ng-serve. This will build the application and launch a web server that will also serve up the application. Our application is compiled successfully. And this is our development server, localhost 4200. And this is our first Angular app. That's how easy it is to create an Angular app using the Angular CLI. Let us now check out some of the benefits that Angular has to offer us. Cost reduction. The amount of work and time is directly proportional to the project cost. Using a framework to build an application reduces a significant amount of work and time required. Angular is standard compliant. It uses ES6, the most recent version of JavaScript. This increases the development efficiency. Angular uses modules. Modules are a modern feature of JavaScript that makes code easier to support. Angular uses modern standards for internationalization and accessibility. This makes our application easier to nationalize for multiple languages and available to those with disabilities. Angular is quite popular, be it from the development point of view or the user. When I say Angular is popular, I mean it has a huge developer ecosystem. Over 443,000 websites built on Angular, 78.7 thousand stars on GitHub repository, approximately 22.9% of the Stack Overflow users, and over 408,000 followers on Twitter. Thus, getting help in Angular becomes easy. Angular documentation is extremely good. It has tons of tutorials, thus learning a lot of different things about Angular makes it even more interesting. Angular is backed by Google and is going to be in the market for a good long time. Now, many giants like Gmail, PayPal, Forbes, Upwork, and Freelancer use Angular on their web application as well. If not me, you can trust these giants on using Angular. Angular architecture. Let us now have a look at various architectural features of Angular. We will check out dependency injection, components, directives, templates in Angular. We will then have an overview of one-way data flow, one of the key performance improvements in Angular over AngularJS. We will then see change detection, Zone.js, and then in the architectural part, we will look how Angular supports multiple rendering targets. Dependency injection. In this code example, we have a component named app component, and this component needs app service instance to do its job. We inject app SVC simply by adding a parameter to the constructor and then marking it with the correct type after the colon, which is the app service. This indicates what dependency to inject. This is the basic of dependency injection in Angular. Next is the component. Let's see how components work in Angular. Here in this code example, this is the metadata for the component. There are many other metadata that can be specified like template URLs, style URLs. However, CSS selector here is the most important one. We have app overview as the selector. This selector instructs the Angular to instantiate this component wherever it finds the corresponding tag in template HTML. That will render its display in the page inside this div after the h1 tag. So by looking at this app overview selector, we will know that there will be an app overview component rendered right here. So this is just a glimpse of how components make Angular crisp and easy. Directives. This is another core piece of Angular. Directives are a way to add new capabilities and behavior to an element in the display, or when we want to change the DOM layout. For example, we might want to highlight an element or make it appear on hover, or give it some other functionalities that isn't already built into the element. Let's see for starter how we can use directives as attribute. Here is an example. This div has an attribute highlight on hover. This directive controls the property of this div. This is a very basic example of directives in Angular. We can even create our own custom directives, which might be complex as well. Templates in Angular. This specify how the components display. Here, we will only focus on one attribute of the template, the placement of the template in relation to the component. In Angular, the template for a component is always separate from the component itself. In this sample component, the template URL specifies the path to a separate file, which is the template. The code for the component and its metadata is here, but the template is in a separate file. We can also use the inline template. In this example, we can see we have template property instead of template URL. This property contains string, which is the template for the component. In this case, the template is adjacent to the component and not in a separate file, but it's not inside or within the component. It is important to note that with Angular, the templates are always separate from the component. Next, one-way data flow. Although we call this an architectural construct, it is really about change detection. For example, this is the parent component and here are the two child components. If some change happens to the state of the component, it causes the child components to also execute a change detection cycle. Each one checks its state. The component is then re-rendered with a new state. Notice that this flow is always one way, never the reverse. Also, once the change detection cycle begins, the state is not allowed to change any further until the detection cycle is finished. Angular actually has checks to make sure that this is true in your code. Change detection is an important topic, and a change will be detected only when there is a change in the state. The state change will always be the result of some kind of event, such as user interaction, or entering data into a text box, clicking a button, or an HTTP request that returns a result, or a timer fires, or any other similar event. When your state changes, you want your framework's change detection to kick in and re-render anything that has changed. Let us look at an example of how change detection works. Let's say we have a first name upon which the full name depends. This full name is displayed here as Hello Anna Hathaway. Now let's say the first name of the displayed user is changed. So here a state is changed. Now with this state change, we may have a cascading change. The user's full name changes because the first name has changed. Once all the initial state change and the cascading change have happened, then we want to re-render our display. Just the display of the user's full name. So this is an example of efficient change detection scenario. The initial state changes, then the cascading changes takes place, and then the display is re-rendered. Zone.js in Angular architecture. This is a key to Angular's change detection. There are a number of asynchronous operations going on in the browser, such as user interaction, timers, HTTP requests, etc. Now the zone creates a wrapper around all the asynchronous operations and any other events that can cause the change in the state. Zone knows when any of these operations complete, and Angular subscribes to the notification from Zone for whenever one of this operation completes. This lets Angular know that it can run its change detection algorithm and re-render anything that has changed. This also assures that Angular minimizes any rendering before a change is completed and thus making it efficient. Rendering targets. it is one of the great advances of Angular. With web framework, we generally presume that we would create a typical website and render it on the browser. However, with the rise of mobile and other needs, it has become advantageous to create the same experience on the phone. Angular, as a modern framework, is built to allow itself to be rendered on any number of devices by changing the rendering engine. This includes the browser, desktop apps, as well as the mobile devices. And to do this, Angular comes with two packages that are used by default to enable rendering to the browser and the DOM. These are the Platform Browser and Platform Browser Dynamic Libraries. So if your application need to run on more devices than just a browser, then you're well covered. Summarizing the Angular's internal architecture, some things we need to remember are: Angular uses components, directives, and templates. Dependency injection is another key part. Angular does one-way data binding. It uses Zone.js to manage its change detection. And Angular supports multiple rendering targets, so it's usable for more than just building websites. Tooling in Angular. One of the great benefits of Angular is the number of tools that are available to add even more features to your application and ease your development. In this tooling part of the guide, we will look at the following topics: the Angular CLI, the one which we used to create Angular project early in this guide; server-side rendering with Angular Universal; frameworks for making mobile and native applications with Angular code; some testing tools; the AOT or Ahead of Time Compiler; and the last one, the editors, which we will use to code in Angular. The Angular CLI. Earlier in this guide, we created an Angular application using the CLI in just a couple of minutes. However, building a complex application using JavaScript implies putting together a lot of pieces, tools, and libraries together first before we even start writing the actual code. We need to take care of module handling, bundling and minifying the code, transpilation from Typescript or ES6 down to ES5 for browser compatibility, using wrappers like Zone.js for change detection, and many more in the production app. This certainly is possible and even easy for a simple project. But in a production app, it becomes a nightmare and brings in a lot of fatigue. The Angular CLI is Angular's answer to this issue. The CLI can create and set up an Angular app correctly. It can create new components, services, pipes, and other pieces of our application. It acts as web server in the development. CLI can also lint our code, test our code, both unit and end-to-end testing. And it can also build our code for production. Makes the task quite easy, isn't it? Next in tooling, we have server-side rendering. Angular uses Angular Universal for this. The server-side rendering concept is very simple, but the implementation is quite complex. We'll take a quick look at the benefit and overall flow of the server-side rendering with Angular. Angular Universal generates the static application pages by processing our templates and creating HTML for each views. The rendered views are then loaded into the CDN. And when a request is sent for this view, it sends a fast initial response. Then afterwards, Universal will make the switch on the client side to a regular Angular application. Once the Angular Universal kicks in, it downloads our entire Angular app, including the Angular framework, and then in a hidden div, it boots the application, renders the current page, and replays any event that the user has done so far to the page to maintain the current state. After this, our static page display is replaced by our regular Angular application. we have our website up and running for our user quickly. Now this may seem simple, but it's really quite complex. And setting it up does require a bit of work, but it could really pay off in the right situations. Now server-side rendering has a couple of key benefits. First, obviously, is the performance. The server-side rendering reduces the initial download size. Instead of downloading the entire framework and templates for other views of the application, we just bring in the HTML and CSS and basic JavaScript for the first page. And thus, the render time is also reduced. This improves the user experience to a great extent, especially on the mobile devices. Next benefit is the search engine optimization. Angular Universal creates a static version of our application, and thus the web crawler can easily search, link, and navigate through our application without JavaScript. This makes a big difference in SEO, since the search engines like Facebook, Twitter, and Google rely on the web crawler to index our application. Next tool in line is the mobile and native framework. Today, most websites receive more views on mobile device than on a desktop. Delivering a mobile app can be a big advantage in the competition. However, they are expensive. As an alternative to building the mobile apps in Angular, we have got tools to create native mobile apps. For mobile apps, we have got Iconic and Nativescript. Iconic has been around for a long time and thus it is popular, whereas Nativescript was built by Telerik fairly recently as compared to Ionic. For native desktop application, recently Electron has taken the scene by storm. It allows to create cross-platform desktop applications in Angular or any other JavaScript framework. With this and other tools, we can create native mobile and desktop applications with Angular, saving a lot of development time and energy. Testing tools. Testing is important and should be supported readily by any framework. Angular definitely falls in this category. There are several testing tools available separately or provided with Angular. We'll just see the important ones. One of them is Karma. It is a unit testing tool installed locally and will run our unit test against multiple browsers depending on how you configure it. It is very fast and convenient. Now, Angular also comes with some utilities that really help out when testing. Number one is the test bed. This is a utility, and it is helpful for us when we want to test components with their templates. It helps us to construct component in a live environment and gives us handles to wrap around the component and the document object model of its template. Next is the fake async utilities. These utilities use Zone.js to run asynchronous code as if they were synchronous, and thus making testing easy. With these testing tools, Angular's testing story is straightforward and fully featured. AOT Compiler. Angular's ahead-of-time compiler is one of the key innovations in the Angular framework. We have the browser and the server. The server where we have the code, the DOM functions, framework, and the Angular compiler. Now the Angular compiles the template on the server itself. So when the browser sends a request to the server, we don't need to send the compiler part of our framework. The compiled view is sent to the browser from the server, and thus no time is lost in compiling those templates into the DOM functions. This saves a lot of time and reduces the download size. If you remember the server-side rendering in Angular, it uses the ahead-of-time compilation. Editors. Editors are most commonly used tools when developing any application. If we give the editor more power, it will make our development faster and easier. And Angular gives this power to the editor. There are two main ways in which the editor can give you additional features using Angular. First is the TypeScript. TypeScript gives two main benefits. First, since you can get the type of an object, you can know its interface. Thus, this gives you better intelligence. For classes and objects, the editor can prompt you with correct properties and methods. And for primitive type, it can prompt you with all the usual properties and methods of those as well. The other benefits of TypeScript is catching typing related bugs. Although not in complete consensus, studies have shown that this can prevent a meaningful number of bugs. Then there is the Angular Language Service. This is an additional tool built by Angular team that provides similar functionality to that of a typing tool like TypeScript. But this is done in our template where there isn't a language per se, just our bindings. This way, we can get autocomplete and intelligence in our template as well as in our code. The Angular Language Service has been adapted to be used in the Visual Studio Code, WebStorm, and Sublime Text. Expect other popular editors to receive the adapters as well. Gotchas and tips. In this section, we'll be looking at some gotchas and few tricks in Angular. Gotchas are the point that could more easily mess you up in Angular, whereas the tips might be helpful to get you around the gotchas or in general. These are subjective and might not stand true from everyone's point of view. However, this might be helpful. Let's start by discussing the gotchas. These are the concepts that might be overly confusing, complex, or difficult to learn. The first one is the TypeScript. TypeScript because it has its own learning curve. Technically, we can use Angular even without TypeScript. However, it would make no sense. If not expertise in TypeScript, basic knowledge is required. The most important thing to learn about TypeScript is how it gives type to the identifiers. In this example, we have the constructor for which the parameter app svc has been marked with the type of app service, which is a class. This is the basic of TypeScript, but this foreign syntax can easily confuse you if you are not used to seeing it. Next we have decorators. Decorators are a very different type of syntax, and each decorator has its own different list of parameters. The basic syntax looks like this. You have one @ symbol and then the name of the decorator followed by the parameters inside the parenthesis. This looks a bit like function, but since they are quite different, it becomes confusing at times. Next is the custom pipes. Pipes are the features in Angular which lets you to format the data. Now this can be difficult because on the surface, creating a custom pipe looks easy, but it is crazy complex on digging just a little. This can easily hamper the performance a great deal if not properly handled. There are two types of pipes, pure and impure. Pure pipes are the default ones. They are simple and easy to use, and are run only when their input changes. This makes them very performant. Whereas the impure pipes are the advanced ones, which are extremely difficult to use properly. This run on every change detection cycle, and this makes it very non-performant. No matter what kind of change happens in the system, all impure pipes are re-evaluated. This can quickly halt an application when not written appropriately. So in summary, pure pipes are simple, whereas impure pipes are very complex. Next we have Module API. It is kind of a big central piece of Angular, but learning the API and the syntax can be tough at times. The Module API contains sections for imports and exports, bootstrap, providers, and declarations, and many more pieces. It is easy to forget to register a component or a service, and this might cause a bug. Here is a basic example of module. We have to remember things like where to put the guards or custom validators, and we also have to register all the pieces correctly. Next gotcha we have is the multiple module. Dealing with it is a special concern. There are two reasons why we create multiple modules. The first reason is to create different modules for each feature area of the application. We'll also create multiple modules when we implement lazy loading. Now generally the challenges that comes up for multiple modules are we have to deal with routing, and next the importing and exporting items from each of the modules is kind of challenging. Generally this is straightforward in most cases, but in case of complex features, it becomes confusing to set up various pieces correctly. Cryptic error messages is another gotcha that Angular has. Even after a lot of improvement, this still remains an issue. It is common to get an error message with software development. However, with Angular, these are sometimes frustrating as they don't always point you in the right direction. The next challenge we have is the build and app delivery size. The deliverable size of our application depends on how optimized our build is. Deploying an app involves putting together many pieces. At the same time, it is important to optimize our build in our Angular application. Now, the deliverable size of our application is directly proportional to the build optimization. More optimized the build is, lesser the delivery size. And on the delivery size depends the performance and speed of our application. Thankfully, Angular CLI can handle a good big part of it, but it doesn't addresses all the complexities out of the build. Initially, when Angular was built, a simple Hello World application was over 1 MB. Despite continuous improvement in this part of Angular, we need to keep a close eye on it. Getting the build wrong can negatively affect the performance of our application. The last on our list is RxJS. Angular heavily relies on RxJS. It handles the asynchronous operations, and this uses observables instead of promises, which is even more complex. Now, promises have been in development since a very long time, so shifting from promises to observables might take some time. Also, the methods in RxJS are subscribed to the observables. So there are few things we need to keep in mind while subscribing the method. We cannot forget to subscribe to an observable. Once subscribed, we need to consider if the method should be subscribed to the observable automatically or manually. Besides this, we also need to take care that we don't subscribe to an observable multiple times. Now, some other complexities in RxJS are the hot observables, cold observables, and the shared observables. Now, with all these gotchas, is Angular really that great? Oh yes, it is. There are ways to mitigate these rough patches in Angular. Let's have a look at them. Now that we have seen some of the gotchas from Angular, we will switch tracks and look at ways to overcome many of these problems, plus few strategies to ease your development. Our first tip is to use the CLI. It mitigates many of the issues that we have seen in the gotchas section, especially around the build. Next tip is to follow the style guide that we have on the Angular IO site. It will keep our project consistent and give us a lot of tips on the good practices. We need to keep the sorting, filtering, and other business logic in our component. This keeps the UI logic in the right place and keeps our performance up. There are few things we need to learn and use while we work on Angular. The first of them is TypeScript. Never consider using Angular without TypeScript. Yes, it has got a small learning curve, but once we learn it, we are going to do great. Next, we need to learn NGRX. This is required for maintenance and performance of our project. Next tip is to learn Webpack. The CLI uses Webpack under the hood. Although learning it is not compulsory, but learning it will be helpful in the development. Use lazy loading. Lazy loading quickly delivers the important first pieces of our application. This, of course, improves the performance. Next tip is to use Visual Studio Code or any other modern editor which supports Typescript. This increases the efficiency of our development. Do not touch or change the DOM directly. Always make changes through the provided Angular APIs to make changes in the DOM. This will make our application more stable and performant. Next is to understand what we are sending down to the browser. This will help in optimizing the build and minimizing the download package size. So instead of blindly using the CLI, we should keep an eye on the download package and the size. Our final tip is for performance. Although Angular is a very performant framework, we can still make it better. Using immutable or observable data appropriately wherever required will improve our performance. This might be a little bit time consuming, but it will be worth it. And this will wrap up our list of tips and tricks. Since the release of Angular, it has proven to be a strong framework and a good option for most web applications. It is fast, modern, and popular. Now, since we have come to the conclusion of this guide, I would like you to give a set of conditions under which you should consider using Angular. If you have an enterprise type company, you can go for Angular. Angular tends to appeal more to this type of companies because of its use of TypeScript and since it is a fully featured framework. You can also go for Angular if you have a typed backend such as C# or Java. Angular will be comfortable for you since it uses TypeScript. Now, if your current application is in AngularJS, I can say that there is no better framework than Angular if you want to upgrade your AngularJS project. The upgrade process is smooth and has least risk when you update from AngularJS to Angular due to the upgrade tool that Angular has given us. Besides all this, we have already discussed all the benefits of Angular. You are well versed with it by now. However, this was my opinion. Angular is one of many alternatives in the market. Choice is yours. Thank you for spending time with Smartherd. Happy coding and keep smiling.